example of how you can filter water. And this sort of membrane, which is called a trackage membrane, can actually be used for cleaning water right down to under 10 angstrom, just about. And that's the sort of thing that these filters look like. They're made commercially and they're sold all over the world for disaster management, for cleaning water quickly for small consumption. You can also go the low-tech way. We developed clay pots that we put a silver-loaded zeolite into, and with that pot you can filter your water in a rural environment where you have no access to clean drinking water, and this particular pot will actually maintain its disinfectant ability and kill off microbes for a long time without leaching large doses of silver into the water. Unfortunately, there are people selling clay pots out there that are just painted with colloidal silver. And what happens with that is when you use them the first few times, the colloidal silver washes off into the water and you're probably getting a toxic dose of silver in. Now we have to look at organics, the element carbon. So the element carbon comes in all kinds of forms, and here are just some of them that are causing trouble. Now, the sources of organic pollutants are coming from industry, from pharmaceuticals, from household products, from personal care products, from industrial chemicals, from fertilizers, you name it. We're completely in love with carbon-based chemicals. Our consumption of chemicals has increased so radically in these last 40 years, and nobody has actually thought about the fact that these things are designed to last. Us chemists are very clever, you know. We don't build planned obsolescence into our molecules. Our molecules are designed to be rugged. They're supposed to go into your stomach, get through your stomach acids, and get to your cells when we're talking pharmaceuticals. There's no planned obsolescence in those chemicals. And when you've finished using them, doesn't mean that they just disappear. They're far more of a problem than plastics. At least plastics you can see. These chemicals are designed to get down to molecular level and have a physiological action. Please remember that. The types of persistent contaminants, you can find these tables on the internet, and we've got some published articles on it. The US EPA lists about 112 priority pollutants. The European Union lists about 58 chemicals. And they're basically saying that if we want to monitor for these chemicals, we should be looking for these chemicals. Your caffeine, yes, your coffee. Each cup of coffee that you drink, all the caffeine from that goes through the wastewater treatment plant into the environment. Caffeine is a very robust molecule, and I'll show you where it ends up just now. Estradiol, that's the female hormone. The female hormone is simply not removed from wastewater treatment plants, and all the contraceptives that we're taking are going into our environment, and they're making all the animals that drink the water sterile. Okay. A chap called Paddington did a study of 7 of the cities in South Africa's drinking water, and he found all these compounds in our drinking water. So let's have a look at that. Benzocaine, paracetamol, carbamazepine, phenytoin. I can't even pronounce some of these things. But they're all pharmaceuticals that are designed for specific physiological activity. And this is in our drinking water. So why should we worry? Chemicals of emerging concern or persistent contaminants are causing feminization, yes, turning males into females. Because remember, a fetus doesn't develop into a male unless it gets the right signals. And if those sites where those endocrine signals are supposed to dock are blocked, those signals can't reach the developing fetus. And we are seeing world over that fish populations are feminizing, and that means the end of the line for fish population. Now, fish are small. We're big. We're a bit tougher. We can take a larger dose. But it doesn't mean it's not happening. Worldwide, semen quality has gone down. And that is why people are having trouble falling pregnant. Because, sorry to tell you guys, you youngsters, you've got about 1/10 of the viable semen that your dad and your granddad had. So it's already impacting on the world's population. It also creates reproductive and developmental abnormalities. A lot of ladies, for instance, have endometriosis. That's displaced tissue from the womb. That's one of the abnormalities that can be caused by taking these compounds in. Endocrine disruption. You can kill off your thyroid by washing your hands with this pink soap that's in the bathroom and not washing the soap off properly. You can kill off your thyroid by using those lip ices that are medicated. Please stop using medicated products. If it says kills 99.9% germs, don't buy it. If it says medicated soap, don't buy it. We're killing ourselves. We're killing the environment. That stuff has got a compound in it called triclosan, or derivatives of triclosan, and it is an antiseptic, which means it kills living organisms. Okay? The other thing that we're doing is we're causing persistent antibiotic resistance. Because of things like triclosan, the microbes have had to evolve to stay alive. So also our overuse of antibiotics is starting to kill off the susceptible organisms, and only the non-susceptible organisms are surviving and multiplying. And it's already considered that we are in a situation now where almost all our antibiotics are ineffective. I think there is one antibiotic left that is effective against sexually transmitted diseases. One antibiotic stands between us and a complete chaos of venereal disease. STDs, big problem in coming forward. Structural deformities, we're seeing in fish and in smaller organisms that limbs are distorted, and we're seeing organs that are distorted. We're seeing sexual characteristics that are hermaphroditic. What's that word? Yeah. And we're seeing things like testicular and thyroid cancers and prostate cancers. So obviously the concentration that you get, the risk of this has got to do with your concentration, your exposure time, your volume, and your metabolism. But you can understand that if you constantly get in contaminated water, you're constantly getting a little dose of this stuff in, and you have a constant chronic exposure to the element carbon, which we all thought was such a safe element. So how to test for these compounds? Well, let me tell you, it is a real mission. So there you see what the doctor is recommending to the patient. Just drink a bit of water. If you want to test for these compounds, you usually have to do it through a specialist laboratory, and they charge you an arm and a leg. These are recent quotes we got per hour for testing for these compounds. You typically have to use this type of equipment, HPLCs, GCMSs, and it is very time consuming because when you sample, you have to sample correctly. Then you have to up concentrate the amount to measurable quantities because it's usually diluted. And then you have to do an extraction of the compound of interest, and you have to derivatize it if you want to use GC. And then you have to find a standard for the compound that you're measuring. And I promise you, many of these compounds, there just aren't any standards, so we can't measure them. We still haven't got the protocols for measuring some of these compounds. So very tricky. Now, we spoke about the SANS guidelines recently, and the only thing that the SANS guidelines says is that the total organic carbon should be less than 10 milligrams per liter. And it says that phenols should be less than 10 milligram per liter. They don't measure for any of these compounds. So it's just as if I took this bottle of water on the table there and said, here, look at the analysis. This water is perfectly safe to drink, but unbeknownst to you, I've thrown a teaspoon of arsenic in there without telling you, and it's not written on there. So actually, sorry, Rand Water, you're selling water that complies to the SANS 241, but you actually don't know what's in that water because you're not testing for it. And many of these compounds are in that water. Okay, we recently did a study about the emerging contaminants and how they got through wastewater treatment plants, because you know in Cape Town the idea is that we should be reusing water for potable purposes. And as far as I understand, in Johannesburg, quite a portion of your water is actually reused wastewater. So it comes from the sewage plant and it's treated up to make it fit for purpose to drink. But if we're not testing for all those compounds are coming through. And let me show you why I say so. So that is the typical wastewater treatment plant. And if you want to go and make drinking water from that, you have to add some stages to that. And typically they would put on a reverse osmosis system there. So we tested several wastewater treatment plants in the Western Cape. You might know Beaufort West has been without water, just like Makanda. And Beaufort West has been using their sewage water for drinking water for quite a while. So that one called Wastewater Treatment Plant A is Beaufort West. And that has actually got a primary, secondary and tertiary water treatment process on it with ultrafiltration, reverse osmosis and UV and peroxide. So that's as good as it gets, guys. That's as good as it gets. And let's have a look. Here we tested for those compounds in those wastewater treatment plants. And you can see that in various parts of that system. I'll go stand on this side so that you can see what I'm talking about. So the inlet water, the clarifier, the sand filtration, the ultrafiltration, the reverse osmosis, and the final water. Okay? So this is for wastewater treatment plant A, as good as it gets. So we found carbamazepine in it, in the inlet water, but it's still in the final water, more or less in the same concentrations, if not more, than the inlet water. In terms of the female hormone, here's the line, that's the safe limit. This is the safe limit, and that's the limit for acute problems, not chronic problems. This is the acute toxicity. Look at what's going through that wastewater treatment plant. All the hormones are going through that wastewater treatment plant. So I think somebody needs to go and do a sex ratio study in Beaufort West. Seriously, where's the Department of Health? Yeah, please go and do a sex ratio study. Well, I think somebody who's into health research should take that up a bit. Okay, so remember that removal in the wastewater treatment plant is not destruction. It just means that the compound has moved phase. It's moved out of the aqueous phase into the solid phase. So if it's still in the water, it means that it's water-loving. If it's in the solid phase, it means that it is attracted to the solids, but it hasn't been destroyed. Those solids are toxic. I'm saying it again. We couldn't test for secondary byproducts, but I can tell you many of these compounds will be broken down when you hit it with UV and peroxide, and if you don't know what you're doing, you make about 40 different compounds rather than the one that you're doing, that you're trying to get out, because they break up and they start reacting with one another. And unfortunately I took the slides out, but even if you treat one compound with advanced oxidation and you don't know what you're doing, you can actually make about 36 different compounds from it. Okay, the removal is highly variable, and it's different for different compounds. And wastewater treatment, water recovery plants, even in the best operational system, are not adequate. I've told you about the phase transfer, and the reverse osmosis also didn't take that estradiol out. So the reverse osmosis is not sufficient of a barrier. And a single advanced oxidation system is also not sufficient of a barrier. Remember, that one had a double advanced oxidation system on it. It had UV light and it had peroxide on. And people are putting that on for the microbial load, but they're not thinking about what happens to these chemicals. Okay, so making potable water from wastewater is problematic unless you know what you're doing. And unless you have advanced analytical capability, I don't think it's a space we should be playing in. Now, I want to just quickly come to the desalination issues in Cape Town. How much time have I got left? 5 minutes. I'll be quick. So in Cape Town, because of the water shortage, the city decided very wisely to go and do water recovery, not from the wastewater treatment plants, but from the sea. But in Cape Town, we are discharging very many millions of liters of untreated sewage into the sea, just a couple of 100 meters away from where they were planning to put the desalination plants up. And you know, because of the water restrictions in Cape Town, all over Cape Town, people have had to reduce their usage, and this is a huge usage map in Cape Town. It means that the effluent that is going into the sea and into our wastewater treatment plants is much more concentrated than it used to be. If you have a look at that, look at the water usage coming down over the last year in 2017. And we're still sitting down towards the bottom end. So our wastewater is extremely concentrated. Now, when we did that study on the effluent treatment plants, it was before the drought. So I don't know what is coming through those treatment plants at the moment. So if we're going to reuse water, we need to think about the whole system. We need to think about the wastewater treatment, the advanced water reclamation plant, and then obviously about the distribution and collection system. And we need a multi-barrier approach towards minimizing impacts. So you can't see it in isolation. So I spoke to you a bit about advanced oxidation. I'm not going to go into it in detail, but a lot of the work that we've done in our lab has been around advanced oxidation and trying to see how well these processes work. And short take-home message, unless you use 3 advanced oxidation systems and you use them properly, you're not achieving your desired goal. Here's, for instance, the removal of a dye out of water using UV light and sunlight with a photocatalyst. Shows you how long it takes. It took round about 300 minutes to get rid of the one compound, so very slow process. We've done the same things with a dielectric barrier discharge system, a plasma system. And there we got the removal rates down to about 60 minutes, or at best, one of the better results, we got the removal rates down to about 20 minutes. And that was using the dielectric barrier discharge system with nano iron.